All right, this is Honors Algebra 2 Pre-Calculus. We are doing 12.1 in Algebra 2, which is measures of central tendency. So measures of central tendency are values that that are often representative of an entire data set. So three of the measures that we're going to see most of the time as measures of central tendency are mean, median, and mode. So the mean is the arithmetic average, which we denote as an x with a line over it of a data set. All that means is that you're adding all of the data together, right? You're going to add all of the data together and divide by the number of values. So just as a quick example, let's say that I have 1, 2, 3, 3, 4. That works. Let's say 1, 1, 2, 3. Okay, so I have 5 terms. So the mean, right, the mean, which would be x with a line over it, would be the sum of those 5 values. So 1 plus 2 plus 3 plus 3 plus 4, right, divided by the 5 values, right? So I'm pretty sure that we get that that's a 13 over 5, right, which is a 2.6. Cool. The median of the data set is the number that's in the middle when the data is arranged in order. So here, right, 1, 2, 3, 1, 2, 3, this is the middle number, right, that 3 in the middle. If there are two numbers in the middle, right, so if there had been two values in the middle, then we would average those two values. We'd take the mean of those two values, right, the mean of the two middle numbers. So here I had 5 numbers, so there was definitively a middle, right? The third one was definitively the middle. If there had been, let's say, 6 values, then the average of the third and fourth value would be my median. So my median, right, in this situation is a 3, right? And then the mode is the number in the data set that occurs the most often. So here, the only one that occurs more than once is the number 3, so the mode is 3. Now, you can have no mode if no number occurs more often than any other, or you could have more than one mode if multiple numbers occur that same maximum number of times. So just as a quick example of that, right? So let's say I gave you a data set that went 1, 1, 1, 2, 2, 2, 3, right? So those are my numbers. So here, the mode is actually both 1 and 2 because they both occur the most, right? They both occur 3 times, right? But if instead I gave you 1, 1, 1, 2, 2, 2, 3, 3, 3, well, now there's no mode because all of them occur the same number of times. They all occur the same number of times, okay? And so there's no mode. So this is an example where there was one mode, only one number occurred the most. Here, 2 numbers tied for how many times they occurred, and here all of the numbers occurred the same amount, so there was no mode. So we're going to go ahead and start by getting a bunch of data sets and finding the mean, median, and mode for all of them. So the first thing you want to do when you have a list of data like this is you want to put it in numerical order. Now that doesn't really matter for the mean, but it's the only real way to find the median, and it makes it a lot easier to find the mode. So what I do is when I list data in order, right, I tend to cross things off as I go. So I'm looking here to see what the lowest number is, and the lowest number I see is 17, and I'm going to cross it off. I look through and I see a 19, I'm going to cross it off. I see 1, 2, 3 20s, 20, 20, and 20, so I'm going to cross those off. I see 2 21s, 3 21s, there's 3 21s, 21, 21, and 21, right? So 1, 2, and 3. I see a 22, and I see a 25, and that's all my values, right? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values total. So there's 10 total that I'm going to use. So I'm going to go ahead and find the sum. When I find the mean, right, the mean is going to be all of these numbers added together. So 17 plus 19 plus, I'm pretty lazy, I'm just going to say 20 times 3, plus I see that there's 3 of the 21s, plus a 22, plus a 25. And I'm going to divide by the 10 total numbers, right? And I'm lazy enough that I'm going to type this in my calculator. So 17 plus 19 plus 60 plus 63 plus 22 plus 25. All right, I'm going to get that that's a 206 over 10, or a 20.6. So there's my mean. So my median, right, there are 10 values. So I'm going to count in 1, 2, 3, 4, 5. These two are the middle together. And you can see that if I count this way, 1, 2, 3, 4, 5, the middle is between them. So the median is going to be the average of the 20 and the 21, right, which is going to be 20.5. And then lastly, the mode is the number that occurs the most. Well, 20 occurs 3 times, and so does 21. So the mode is both 20 and 21, right? Both of them together are the mode. All right, so go ahead and give that a try. Again, you have a data set here. Put it in order and do your thing. So I look through here and I notice that the lowest number I have is an 18. The next number I see is I see two 24s. So there's 24 and a 24. I see a 26, 38, 39. So 38, 39, 42, and 48. And again, you don't have to cross things off, but I find it surprisingly easy to miss something if you don't. So here are my values. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms, right? So there's 8 total. I'm just going to circle that so I don't forget. So my mean is going to be the sum of the 18, 2 of the 24s, 26, 38, 39, 42, and 48, all divided by 8. So 18 plus 48 plus 26 plus 38 plus 39 plus 42 plus 48. All right, and divide that by 8. So I get that this is a 259 divided by 8. And I don't have to put an approximately symbol because it actually is 3 places after the decimal. I'm neither rounding nor truncating. That is actually the value. Now the median is going to be the middle value, but here there are 8 values, which means there are 2 values in the middle, right? The middle actually occurs right between these two. So the median is going to be the 26 plus the 38 divided by 2, which should give me a 32. We can double check in case, but 38 plus 26, yep, divided by 2. So we get 32 for the median. And then the mode is the number that occurs the most often. Here there's only one number that occurs twice. Nobody else occurs more than once, so the mode is the 24. All right, so let's do a little word problem. The salaries of a small business with 7 employees are as followed. Find the mean, median, and mode, and which one is the best measure for a typical employee's salary. So I'm going to add all these values together, right? If you wanted to treat them just as the numbers before the thousands, you could, and then you could just add 1,000 on the end. So I'm going to go ahead and put them in order, right? So the lowest salary seems to be 22,000. So I'm actually going to say in thousands because I don't feel like writing all those numbers. So 22,000, 22,000, 24,000, 28,000, 30,000, 32,000, and 255,000, right? So those are all my values. So the mean, right, is going to be the sum of all those numbers. So 2 times 22 plus the 24 plus the 28 plus the 30 plus the 32 plus the 255 divided by the 7 employees, which I don't have to count because they told me there were 7. So that's going to be 44 plus 24 plus 28 plus 30 plus 32 plus 255. So I'm going to get that this is a 413 over 7, right, which is a 59. So the mean is $59,000, right? So it was the mean was 59. So in thousands, right? And then when I changed it to $1,000, that's what I get. The mode, sorry, we usually do a median next, my bad. The median is going to be the middle number. Well, there are 7 employees, so there's going to be an odd man out. There's 3 on either side, so the median is $28,000, right? And then the mode is the number that occurs the most. Well, that's the 22. So the mode is the 22,000. Right, that's the one that occurs the most. So which one is which best represents the typical employee salary? And so the issue here, right? The issue here is that this average. So this is not right because everybody at the company makes way less than this. In fact, about half of this or less than half of this. The only reason this is so high is because this person makes a lot of money. So this is not a good representation, right? This is much higher than everyone except probably whatever that is, right? CEO or whoever that job is, right? But that's the only person getting that much money. So that's way too high. This is probably not the most representative because this is actually the bottom possible salary, right? So although it's the one that occurs the most, maybe that means there's more entry-level employees, that's significantly lower. This is probably the one that is the best representation, right? It's kind of in the middle of the value set numerically, right? It's not the highest salary, but it's also not the lowest, and it's not really impacted by that 255. So best representation, okay? So it's probably the 28,000. All right, same idea. Yearly bonuses for 5 managers are given here. Again, in thousands of dollars, so you might want to do it by thousands. Find the mean, median, and mode and explain which one's the most representative. So again, if you wanted, you could say something like in thousands and then just list the numbers. So 0,000, 80,000, 85,000, 90,000, and 100,000, right? Sorry, that's an extra zero. All right, so the mean, right? The mean is going to be 0 plus 80 plus 85 plus 90 plus 100 divided by the 5 people, right? So that's, I can just skip the 0, right? So 80 plus the 85. So I can skip the 0 in adding, but I need to understand that I'm still dividing by 5, right? That 0 factors into the total bonuses because there are 5 people divided by 5. And I'm going to get that we're talking 71. So we're talking $71,000 for the mean bonus, right? The median, my bad. The median's the middle number, so the median's going to be the 85, so that's an 85,000, right? And then there is no mode because they all occur the same number of times, so there's no mode. So that's definitely out of the running for being the best representation. So the argument would be that the best representation of the bonuses in general is probably the 85, right? Because, so if you look at this, this is all kind of in the neighborhood of the 85. This is pulled way down by the 0. So this is pulled way down by the $0, right? So realistically, I think the 85 is probably the better estimate, right? So this is the best estimate of the options. That's not to say that it's a great estimate, but it's more likely that somebody who is getting a bonus from this company is going to get something in that neighborhood instead of the 71. All right, so let's talk about frequency tables. Frequency tables are a great way to analyze data when you have a lot of points that have the same value. So for instance, if we looked at the ages of everyone in this class, we'd find that the majority of folks are 14, 15, or 16, and there will be a few 13s, and I'm rocking a solid 41 right now at the time of this video being made, but most of you are 14, 15, or 16. So if we made up some fake hypothetical data for 33 people in a class, see, there's our fake hypothetical data, what we can do is we can make a frequency table. So I'm going to go ahead and make the pen slightly thinner, and we're going to talk about how to make a frequency table. So here's my data. What a frequency table looks like is when you have a ton of the same numerical values, you put tally marks. So I see a 14, I put a tally mark. I see a 15, I put a tally mark. I see a 14, I see a 16, 15. And yes, this is tedious, but it's a lot less tedious than the other options. 16, 14, and I'll show you what I mean by that in a minute. 13, another 14. When you hit 5 on tally marks, you cross through it to show that you hit 5. 15, 2 more 15s. I'm just going to go ahead and do that now. 2 more 15s. I see a 16. All right, I've got a 14 and a 16. I'll just save us a little bit of time by doing time. So I have 15 and 2 14s. So a 15 and 2 14s. 16, 13, oh, I have one of each, right? 16, 13, 14, 15. So 16, 13, 14, and 15. 16, 13, 14, 15. 16, 13, 14, 15 again. So 16, 13, 14, 15. And then one of each again, right? 16, 15, 14, 13. So 16, 15, 14, 13. 16, 15, and 41. So 16, oh, wrong one. There was the 15. 16, that was the 15 I just put, and 41. Okay, so frequency, there were 4 people that were 13, right? There are 11 people that are 14. There are 10 people that are 15. There are 8 people that are 16, and there's the one me, right? And if we check our math on this, we should come out with 33 people. If we don't, something went wrong, unless, oh wait, I said 33 people. That might have included, oh, I make 34. There you go. So 34. So if we check our math on this, this is a 15, right? 15 and 19, sure enough, gives me a total of 34. So yay, 34 people. Okay. So the nice thing about a frequency table like this is going to allow us to find things like mean, median, and mode a lot faster, right? So I'm actually going to go ahead and take a screenshot of this tally because I don't feel like remaking it on the next window. Yeah, that works. Okay, so let's use our frequency table. Okay, so I'm just going to open this for a sec so that I can 4, 11, 10, 8, 1. 4, 11, 10, 8, 1. So 4, 11, 10, 8, and 1. And we know there was a total of 34. Okay, so we can use this frequency table to easily find the mean, median, and mode. Okay, so the first one, in order to find the mean, I would normally write out 13 4 times, and 14 11 times, and 15 10 times. But why, when I recognize that 13 times the 4 times I'll see it is a 52, right? 14 times 11 is going to give me a number I don't feel like doing in my head. 15 times 10 is going to give me a $1.50. 16 times 8 should give me a $1.28. And 41 times 1, because I'm just me, is a 41. 14 times 11 is really a thing I just don't feel like doing in my brain right now, so I'm not gonna. So oh, there we go. Come on, calculator. Need you to be slightly faster, because you're a calculator. All right. There we go. All right, so 14 times 11 is a $1.54. So if I get the total of this, right, if I add the 52 plus the 154, sorry, it's a little bit laggy, plus the 150 plus the 128 plus the 41, that's the sum of all those values, right? That was a shortcut way to get to the sum of all those values. So 525. So my mean, right, is going to be 525 divided by 34, which I can do pretty easily. So that's, if you have a lot of data with the same value points, it's really helpful to make one of these. And so my mean is going to be approximately 15.441. And that's not super surprising, because if you notice, the two numbers that we have the most of are 14 and 15, right? But my 41 is going to drag that average up significantly because it's a lot farther up than the other numbers. So the median is actually not awful to find either, right? If I have 34 of these things, the median is going to be the average of the 17th and 18th terms, right? The 17th and 18th terms in this list. So the easiest way to do that is to realize that this is 15 terms. So 16, 17, and 18, they're both going to be in here. They're both 15. Both are 15s. Once I know that my median is the average of 15 plus 15 over 2, which is just 15. So even though technically it's not a number from the set, it's the average of two numbers, both of those middle numbers fall in the window of the 15. So once I know that, it's easy enough to figure out. That that's a 15. And then the mode is also easy to spot, because we saw that 14 occurs the most. 14 is the most frequent. It occurs 11 times. So that's kind of the gist. So you survey some friends about how many MCU movies they've seen. The responses are below. Make a frequency table for the data, and then use that frequency table to find the mean, median, and mode. So let's go ahead and make a frequency table. So I see a 12, and a 13, and a 16, and a 13. Now I cheated and already made the table to only have the numbers that I know occur in the list, right? You'd have to make that table to only include the numbers on the list, but I cheated and did that already for you. 15, 16, ooh, somebody's a fan, 23, 20, 13 movies, 15 movies, 4 movies. Notice that everyone on your timeline had seen some Marvel movies. 13, 14, 13 again, 20 again, and 4 again. Okay, so in terms of frequency, 2 people had seen 4 movies, 1 person's seen 12 movies, 6 people have seen 13 movies, 1 person saw 14 movies, 2 people saw 15 movies, 3 people saw 16 of the movies, 3 people saw 20 of the movies, and 1 person was killing it and saw 23 of the movies. So the product of 4 times 2 would be the 8, right? 12 times 1 is 12. 13 times 6 should be an 18 and a 60, right? So that should be a 78. 14, 30, 48, 60, and 23, right? So I surveyed a bunch of friends. I should figure out how many friends I surveyed, right? So I do need to total these numbers. So 2 plus 1 gives me 3. That's 9, 10, 12, 15, 18, 19. So I surveyed 19 friends. And you can check that by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yay, checks out. So I'm going to sum all these numbers, right? So 8, there we go, 8 plus the 12. It would help if the calculator was slightly less laggy. Second, insert 8. There we go. All right, so now that we've got the 12, we have a 78, 14, 30, 48, 60, and 23. Double check those numbers, 8, 12, 78, 14, 30, 48, 60, 23, enter. So the total is 273. I'm going to divide that by 19. And I'm going to get that the mean is that 273 divided by 19, which is approximately 14.368. And that fits, right? Because there were a decent number of people under 14, but there's a lot of people over 14, so that seems about right. Now the median, since there are 19 of them, right? If there are 19 terms, then there's going to be 9 terms, then this mystery term in the middle, and then 9 terms on this side. So basically, I would count 10 terms in. So 2, 3. This will be the 9th term, so 10 terms would be right here. This would be 10. So the median should be that 14, right? Because I counted in, and you can check on this side too, right? You should have 1 plus 3 is 4, plus 3 is 7, plus 2 is 9. Hey, look, there's 9 terms. So the median is that 14. And the mode is the one that occurs the most, right? The one that occurred the most was definitely the 13, right? So there you have it. So you can also make grouped frequency tables, and these are useful if you want to look at groups within larger data sets. You'll see them a lot on surveys where your age is requested. For instance, under 18, 18 to 24, 25 to 34, etc., right? So when surveys ask your age, they're not actually usually asking, are you 18 or are you 19 or are you 20? They're asking for an age window. So they don't actually know how old the person filling the format is. They just know which window you fall in. You make a similar tally chart, right? But instead of for individual values, it's for groups that are for numbers that fall in that group, right? And then you can use the mean of each group to estimate the mean for the entire data set. So here's an example. Here, the grouped frequency table was already made for us. So we have 80 musicians that were surveyed. They were asked how many hours per week they spend practicing. 13 people said 1 to 5, 9 people said 6 to 10, et cetera, et cetera. So we're going to estimate the mean number of hours that the musicians practice every week. So to do that, what we need to do is we need to estimate the mean of each group. And then we say, okay, whatever the mean of 1 to 5 is, right? The mean of the numbers 1 to 5, that's going to be the mean we use 13 times, right? So basically to do this, we need to find a group mean for each one of these windows, right? And I'll use the smaller pen because it's easier to deal with, right? So the mean of the numbers 1 through 5, right? So 1 plus 2 plus 3 plus 4 plus 5, right? That's 5 numbers. And then I could divide by 5. Right? The mean of those values is 3, right? It's actually totally sensible. If you think about it this way, it's the middle set of the numbers, right? Like if you look at the numbers, and we don't even have to do it for all of them, 6 through 10, the mean is going to be the middle number, 6, 7, 8, 9, 10, because 6 and 10 will average to 8, and 7 and 9 will average to 8, and then 8 is 8. So similarly, the middle between 11 and 15 is going to be 13, and you could figure this out by actually finding the mean in all of them, but once you spot the pattern, it's not really worth doing that. So 28, 33, and 38. So it's all the 8s and the 3s, right? So that means that my mean is going to be approximately, and then I'm going to take this mean times the total number of hours. So 3 times the 13 times the total frequency. So this mean times the total frequency. So 8 times the 9 plus the 13 times the 9 plus the 14, plus the 18 times the 14, right? So this one, this one, this one, this one, plus the 23 times the 16, plus the 28 times the 8 plus a 33 times an 8 plus a 38 times a 3 all of that is going to be over the total of 80 musicians, but that's kind of a mess. So you can see that this is a little bit time consuming. I'm not going to make you do this on a test. I'm not going to make you do it as a project, but I want you to get how these numbers can be calculated. So when averages are used for groups like this, they're not actually using the people's actual age. They're using the mean of the set that they were given for ages, right? 13 times 9 plus 18 times 14 plus 23 times 16 plus 28 times 8 plus 33 times 8 plus 38 times 3. And double check that that's right because that's a lot of numbers. 8 times 9, 13 times 9, 18 times 14, 23 times 16, 28 times 8, 33 times 8, and 38 times 3. Enter all of that work to get that this is approximately a 1450 over 80. And so we get approximately 18.125 hours per week. Now, a thing to notice here is the approximate symbol isn't because I averaged or because I rounded or truncated this. The approximate symbol is because I'm estimating the mean. Because I don't know how many of these people only practice 1 hour a week. They said 1 to 5. They might all practice 1. They might all practice 5. I don't know. I'm using the mean for that group to kind of make an estimate, okay? Cool. So, sorry, going back. Went the wrong way. All right, there we go. All right, so the last problem we're going to do is the same concept, right? You're going to do the same thing, but you're going to estimate the mean for the number of books that people read. I'm sorry, the number of magazines they read each month. So you'll notice the same situation happens here. This is the number 0, 1, 2. The average of 0, 1, and 2 is the middle number. It's 1 because they're all 1 unit apart. The average of 3, 4, 5 is a 4. The average of 6, 7, and 8, if you add those numbers together and divide by 3, will be the 7. The average of 9, 10, and 11 will be the 10. So your mean, and again, I didn't just guess this, right? I did 0 plus 1 plus 2 divided by 3 and realized I got a 1. And then I started to spot a pattern, right? 3 plus 4 plus 5 divided by 3 ends up giving me a 12 over 3, which is a 4. And I realize, oh, hey, I see. It's the number that's in the middle of all of these. So my mean is going to be approximately a 1 times the frequency of 10, a 4 times the frequency of 12, a 7 times the frequency of 4, and a 10 times the frequency of 4, all over the 30 people that were asked, right? So that's going to be a 10 plus a 48 plus a 28 plus a 40. So I'm going to get that this is a $1.26 over 30, which I would then approximate. If we get the 0, there's the 0. Okay. To be 4.2 magazines per week, right? And because there are units, I want to include units, magazines per week. And that's the end of this section.